We saw earlier that lots of times probabilities or counts of bigrams or trigrams would be 0. What do we do in these cases? Let's think about this by starting with what's called the Shannon visualization method. And this is what Shannon proposed to visualize the actual n-gram grammar that you've built by maximum likelihood estimation. So here's the method. We choose a random bigram according to its probability. So this is a bigram with start as the first word and then any other word according to its probability. Roll a die and pick whichever bigram comes up. So let's say we picked I is very likely first word. So we pick start I as our first bigram. Now we choose another random bigram that starts with that word W we just generated and whose next word is chosen according to its probability. So now we pick want. So now we've picked I want. And now we go on until we happen to choose the end of sentence. So I want to eat Chinese, Chinese food, food, end of sentence. Ah, there we go. So now we string these words together and we've generated a sentence. So the Shannon visualization method can show us a lot of things about the n-grams that we've built. So for example, here's a grammar language model trained on Shakespeare and generating random sentences. So here's some unigram sentences. Every enter now, severally so let. Hill he late speaks, or. Not very good sentences. How about our bigrams? Why does stand forth thy canopy, forsooth? He is this palpable hit, the King Henry. Live king, follow. Oh, this is better. This is beginning to sound like Shakespeare. How about this one? Indeed the Duke, and had a very good friend. Well, that sounds pretty good. Sweet prince, Falstaff shall die. And now let's look at the quadrigrams. It cannot be but so. Will you not tell me who I am? That sounds very good. Now, Shakespeare produced 800,000 words with a vocabulary of 30,000. And it turns out that in those 800,000 words, he produced about, those 30,000 words, he produced about 300,000 different bigram types, so different unique pairs of words. But that's 300,000 out of 30,000 squared, or out of 844 million possible bigram. So if we multiply that out, 99.96% of the possible bigrams were never seen. Those are going to have 0 entries in the bigram table. Vast number of zeros. So that's just bigrams. Quadrigrams are even worse. So the reason why those quadrigrams looked like Shakespeare is because those were actual Shakespeare sentences, because following any particular quadrigram, really only one possible word could occur in such a small corpus as Shakespeare. And we can see that if we look at a different corpus like the Wall Street Journal, it's not Shakespeare. So for example, here's some trigram sentences from the Wall Street Journal. They also point to $99.6 billion from 204.06, 3% of the rates of interest stores as Mexico and Brazil on market conditions. Well, that sounds like the Wall Street Journal. But here's 2 corpora of English, both reasonable size corpora, millions of words, or at least a million words. No overlap at all in the Shakespeare sentences and the Wall Street Journal sentences. So what's the lesson from this? One lesson is the perils of overfitting. N-grams only work well for word prediction if the test corpus looks like the training corpus. If you test on Shakespeare but you trained on the Wall Street Journal, you're not going to predict words very well. So in real life, this just doesn't happen. So we'd like to train robust models that do a better job of generalizing. And I want to talk about one kind of generalization, which is dealing with zeros. So by zeros, I mean things that never occurred in the training set, but do occur in the test set. So let's look at some zeros. Imagine that in the training set, we had phrases like denied the allegations, denied the reports, denied the claims, denied the request. And we never saw denied the offer. So the probability, based on maximum likelihood estimation, of offer given denied the is 0. Now we go to a test set and we see there's a sentence denied the offer and denied the loan. What's the probability of those sequences denied the offer and denied the loan going to be? Well, the probability is going to be 0 because we've trained our probabilities on our training set. We're going to do a very bad job. If we're a speech recognizer, we'll never recognize this phrase. If we're a machine translator, we'll refuse to translate into this phrase. We're going to claim this phrase is just not good English. So this is a big problem we need to solve. So bigrams with 0 probability mean that we're going to assign 0 probability to the test set. And so we can never compute perplexity. We can't divide by 0. So we're going to need to find a way of dealing with bigrams with 0 probability.